In the previous tutorial, I showed how to use the code from the ray test code snippet to add a paint splat graphic to an object. In this tutorial, I'll show how to use the technique to make a simple game. The starting point for this tutorial is the Blend for Web project that I made in the previous tutorial. I recommend you watch the previous tutorial, and you can download the Blender file and the JavaScript file from my website and use them to recreate the project. First, I'm going to look at the code that adds the graphic, and for the game, the code that adds the graphic to a moving object. Clicking the edit link to look at the JavaScript file, the .js file. The code is in the init logic function. Scrolling down, this is where an event listener is added. It listens for a mouse down event, a mouse click, and when it hears one, the mouse callback function is called. This is the function that performs the ray test, and if any object is hit, the ray test callback function is called. Scrolling up, I'm going to add these two lines to the ray test callback function. Right click, copy, click, right click and paste, and save the changes. In the Blender file, I'm going to change the physics of the can to rigid body so that it falls with gravity. I have to re-export the scene. Then I'll look at the console messages I get when I click on a moving can. Now when we reload the scene in a web browser, the can falls with gravity. The graphic is added to the scene but not attached to the can. If we look at the messages sent to the web console, the first message is the object that was hit. There is a long list of the object's properties. The first property is the name of the object, which is cylinder. The second message is whether the object was animated, and because it is false, it's assumed the can was static and the graphic wasn't attached to the can. Going back to the code and scrolling down to look at the ray test callback function, this if statement picks up if the object is animated, if the hit object is moving, and if it is, it uses the append stiff function from the constraints module to attach the decal graphic to the hit object. In this version, I've animated the can using keyframes. When I click on the can, the graphic is attached to the can because the is animated returns true. So this version of the code works for objects animated by keyframes, but doesn't work for objects moving due to gravity. Next, I'm going to make a simple game where the objects are moved by gravity. First, I'll set up the Blender file, then I'll explain the code. Change Blender Render to Blend for Web and click Set Recommended Options. In the Object Properties, set the Y scale of the cube to 12, the Z scale to 0.25 and the Y rotation to 10. Select the lamp. In the Object Data Properties, change the type of lamp to Hemi. Select the camera. For the ray test to work, in the Physics Properties, click Object Physics. In the Object Properties, set the X rotation of the camera to 90 and the Z rotation to 0. If I right click on the camera's location, I can reset all the values to 0. If I set the Y location to -50 and zoom back, there's the camera. Next, I'm going to append the target object into the scene. File Append, go to the folder where you have the target model file, click on the file to go into it, go into the Object folder, select the target object and append. I made the target object by selecting the ring of edges around the top of a cylinder. I then extruded and scaled, and then assigned different colours to the rings that were made. Make sure the target is selected, set its X rotation to 90, its Z scale to 0.5, and click Apply Scale and Modifiers. In the Physics properties, click Object Physics, change the physics type to Rigid Body, click Collision Bounds and change the collision shape to Cylinder. I didn't set the physics properties of the ramp. Select the cube, click Object Physics and Collision Bounds. The target is the master for a set of duplicates. I'm not going to use the master, so I'm going to hide it behind the camera by setting its Y location to -55. Next, I'm going to append the decal into the scene, just as I did in the previous tutorial. File Append, go to the Blend for Web folder, the Blender folder, Code Snippets, Ray Test, click on the file to go into it. In the Object folder, click on the decal model and append. It's inside the cube, so we can't see it. So I'm going to select it in the outliner window, and as before, I'm going to press S to scale, 4 and enter. And because it will be duplicated, we must tick Apply Scale and Modifiers. To set up the background, click the World Properties, click Render Sky, Blend Sky and Real Sky, click the Horizon Color and set the red value to 0.2, the green value to 0.3 and the blue value to 0.4. Click the Zenith Color and set all three values to 0.8. That's the Blender file ready to use. Before I save it, in File External Data, make sure Automatically Pack is checked. I've already made a new project. I'm going to overwrite the dummy Blender file. File, Save As, Blend for Web folder, the Projects folder. The new project is called Ray Test 4. The Blender folder, click on the Blender file and click Save As to overwrite it. And to overwrite the JSON file, File, Export, Blend for Web JSON, make sure you're in the Ray Test 4 Assets folder and export. And don't forget, if you want a sound effect to play when a target is hit, to add a speaker object to the scene with its behavior set to background sound and linked to the sound file. Any changes made to the Blender file, you must remember to re-export the JSON file. Now for the code. First, I'm going to look at the changes that I've made to the init logic function compared to the last tutorial. When the mouse clicks on an object, when the ray test hits an object, the ray test callback function is called. In the scene, there are only two things you can click on: the targets or the ramp that they roll down. If the object that is hit is not the cube, the ramp, then it must be one of the targets. So we play the sound effect, add 1 to the score, and update the score display. I've taken the if the object is animated statement out by making it into a comment which is ignored by the computer because the targets are moved by the physics engine, not by keyframes. We need the append stiff function to attach the decals to the targets. Before we move on to the next new function, I want to look at these 2 lines. I hide the original decal, which is a paint splat graphic UV mapped to a mesh plane. I hide it behind the camera. It is used as the source for copies which are made every time a target is clicked on. The next function makes multiple copies of the target. The source object is the target, and as below we make copies of the source object. The targets are rigid bodies and their locations are controlled by the physics engine. To initially place the targets, we have to disable the physics engine. Then we can set the location of the targets before re-enabling the simulation. For each new target, I increases, so the X location increases, moving the new targets to the right. And because of the minus sign, the Z location decreases, moving new targets down. I have also added the JavaScript set timeout function, which delays for 8 seconds before displaying the message press F5 to play again. That's the end of the tutorial. I'll put all the files used in the tutorial for you to download at my website. To visit my website, click the eye icon in the top right hand corner. If you'd like to subscribe, click the stickman. If you'd like to sponsor my tutorials, click the Patreon link. Thanks for watching and goodbye.